Hi passionate scientists, my name is Jorge and today I'm providing you a couple of problems in physics. You're gonna learn at least a little bit after seeing this video, take that for granted. So now to start with, we're gonna speak about this trajectory, okay? We have the following trajectory with an initial velocity and we just decided to take this point at our origin of coordinates and we're asked for describing or characterizing R, okay? So I advise you to stop the video and try and for yourself the problem and see you right now. Hi again for everyone, and now we're going to describe or we're going to solve this problem. So now I'm going to remove this paper from here and let's shed some light on it right now. So as we all know, the differentiation or the change in distance per change in time is defined as velocity, and we just have to solve this differential equation and integrate it on both sides, and we obtain the following equation on x. This is x, just solve for x axis, because as is evident, the initial position from x-axis from the point of view of x-axis is 0, also for the initial time. Okay, so right here we are going to define, we're going to study x and y-axis. For the x-axis, the equation for velocity, the equation for distance in function of time and initial velocity is the following: as we have this angle, as is clear, and by trigonometry it's clear that it's by initial velocity per cosine of angle, initial angle, no? So we have the first equation, and then we want to describe error, but right here we have the time, so we have to look up for another equation that has time to just plug in and just solve for error. And that's why we go to y-axis. So right here we just do the same, we just integrate on both sides and we obtain this equation, but right here we have an initial distance that is h, okay, concretely minus h as it goes down, okay? So right now we have this velocity, okay? But as we know, the acceleration is considered constant, and because of it, velocity is heightening in a constant way. That means that velocity, or medium velocity, and instant velocity are equal. Therefore, we know that we can define the velocity as the final velocity plus initial velocity divided by 2, okay? And now we have final velocity and initial velocity, but now we have to have our equation in function of one of those terms. So obviously it will be in terms of initial velocity. So now we have to look for another equation for velocity, and that's obvious that we can't do it by knowing basic calculus, that the change in velocity per change in time is equal to the acceleration. So applying the same method right here that we did right here, we obtained the equation of the final velocity equals of initial velocity plus acceleration per time. So now, knowing that, we plug in this equation right here, and also we plug in this equation right here, and we obtain this equation. Okay, it's clear now for everyone. I just wanted to prove it technically, you know. So now we have this equation, and we just have to do a little bit of algebra, you know. Minus h, as we all know, y. Obviously, the acceleration is negative, and right now we just do a little bit of algebra. We do a second grade equation. We just solve for t. We solve for t. We do a second grade equation, and this is what I obtain. I hope not to be wrong right here. If I had mistaken, please just leave me in the comments. section. So now we are going to do, or we are going to study the second trajectory I prepared. Okay, so let's just have a look. Wait a second, I don't want to. Okay, so right here. So we have this trajectory right now. So this is our original coordinates, and right here we have the air bodies, the hypotenuse of this right angle. Okay, so we are asked again with, or we are asked for solving air now. So as before, I suggest you stop the video and trying for yourself. So see you. Hello again, and now we're going to solve it. As we are interested in the hypotenuse, we're going to focus on directly y-axis, as we want to have this y or final y as I named it involved. We want to get involved this y. Okay, sorry. So now we just do the same. This is the same equation we know, and we know that the velocity per sinus of theta is this height, you know, and for the same reason. And now we also have the time trouble as before, but we can define the time per the definition we all know. You know, velocity is equal to space per time, and as we know, velocity of x can be, or is defined actually, by v cosine per theta, or initial theta. Okay, so right now we just do again some algebra. Okay, so now we just plug in t, and as we know, yx is the phi angle, or if we focus on the phi angle, we can easily solve for yf. We know it's r per sine of theta, and just we solve it. We know that it's a tangent, and just do a little bit of algebra. I hope not be wrong right here, and this is the solution I got, so check it out. So the video finishes right here. I hope it was helpful for all of you, and see you very soon. Goodbye and keep improving.